The topic of this video is adding and subtracting unlike rational expressions. Let's look at a problem. Subtract, simplify. 6x over x squared minus 4, subtract 2 over x squared plus x subtract 6. Alright, in order to subtract unlike rational expressions, we have to use two of the previously learned objectives in a single problem. The first thing we need to do is to make our two fractions like. We need to make them have the same denominator but be equivalent to what we have been provided. The second thing we have to do is then subtract the like rational expressions. Okay, let's begin. So the first step we need to do is to make these like. And the first step of that process is to factor the denominators. So we get 6x over x plus 2, x minus 2, minus 2 over x plus 3, x minus 2. Next, place needed factors in the top and bottom of each fraction so that the denominators match. The first fraction is missing an x plus 3 top and bottom. The second fraction is missing an x plus 2 top and bottom. Now the denominators match, and we have turned our unlike rational expressions into equivalent like rational expressions. This is kind of like the p over q minus r over q that we discussed in a previous video, where q is an x plus 2, an x minus 2, and an x plus 3. An x plus 2, an x minus 2, and an x plus 3. So when we combine two rational expressions of this type, we're going to keep the common denominator. But before we do that, we need to distribute here and here. So we get 6x squared plus 18x over our common denominator of x plus 2, x minus 2, x plus 3, minus 2x plus 4 over our common denominator of x plus 2, x minus 2, x plus 3. Now we can use this rule. Keep the common denominator, subtract the two numerators. And if your second numerator is more than one term, then you must put it in parentheses. So we're now going to keep the common denominator, x plus 2, x minus 2, x plus 3, and we're going to subtract the two numerators, 6x squared plus 18x minus the 2x plus 4. And because 2x plus 4 is more than one term, we have to put it in parentheses so that the subtraction is distributed to both of its terms. All right, so now we're going to have 6x squared plus 18x minus 2x minus 4 over the x plus 2, x minus 2, x plus 3. Combining like terms, we get 6x squared plus 16x minus 4 over x plus 2, x minus 2, x plus 3. Now that we've combined our fractions into one, we have to check to see if this can be simplified. The first step of simplifying is to factor all numerators and denominators. As you can see, our denominator is already factored, but we need to try and factor the numerator to see if there's anything that can cancel top and bottom. The three steps of factoring are descending order, which this is already in, GCF, which is 2, and then counting our terms. Let's take out the 2. So from the numerator, if you divide everything by 2, you'll have 3x squared plus 8x minus 2 over x plus 2, x minus 2, x plus 3. Now we have to see, can we factor this trinomial? The leading coefficient of the variable squared term is not 1. Therefore, we consider using the AC method to try and factor that trinomial further. Maybe it's factorable. Maybe it's not. But until we try, we won't know. So, 3x squared plus 8x minus 2. We're already in descending order. There is no GCF. A equals 3, B equals 8, C equals negative 2. A times C equals 3 times negative 2, which is negative 6. So we need two numbers that multiply to make negative 6, but add to make B, which is 8. So, can we find a pair of numbers that has that property? Let's make a list of all of the numbers, all of the integer numbers that multiply to make 6. It's a pretty short list. 1 times 6, 2 times 3. And because it's actually technically a negative 6, we can make two lists. One list where the first factors are negative, and the other list where the second factors are negative. Now we're trying to find a pair of numbers that adds to make 8. Negative 1 plus 6 is 5. Negative 2 plus 3 is 1. 2 plus negative 3 is negative 1. 1 plus negative 6 is negative 5. None of these pairs of numbers make 8. What that means is that this trinomial is prime and cannot be factored, and therefore, this is our final answer. Although it is inconvenient, we must always check to see if our numerator trinomial can be factored when working with problems of this type, because if it can, it is possible that we will need to cancel a factor up top with a factor down below.